Okay, for this video, we're doing 3.2 complex solutions and zeros. Okay, so we're going to solve quadratic equations. So a quadratic equation would be something like x squared plus 4 equals 0. This is a sum of two squares. We did a video earlier on difference of squares, but this is sum, and we just can't factor this. We wouldn't be able to solve this by taking square roots either with real. There's no real solution to this. So if we isolate our squared term, we subtract 4 from both sides, we're left with x squared equals negative 4. Up till now, we've stopped the problem and said there's no real solutions. That's true, and that's because there are imaginary solutions. And so we'll go ahead and take the square root of both sides. We'll get x equals, and remember, this is where we want to show that plus minus. Plus or minus, square root of negative 4 is basically this. You would solve this almost as if you were doing the square root of positive 4 plus or minus 2. It's just that you need to add the I here, because this is root 4 times root negative 1. And so that's 2, and that's I. And that's our 2i. We're taking the plus or minus because this is a variable. So in those other problems that we did, I said, oh, just take the positive root. That's because we knew what the number was. But here, we don't really know what the number is, and so we have to take both possibilities. Okay, that's one example. Let's do one that's a little more complicated. That was example A on page 107. Let's look at example B. B is 2x squared minus 11 equals negative 47. We'll just go ahead and add 11 to both sides. And we get 2x squared equals negative 36. Dividing by 2, we get x squared equals negative 18. Okay, again, in the past, no real solutions. So what are the imaginaries? Well, we take the square root of both sides, and we get x equals plus or minus the square root of 18. Okay, so let's just simplify the square root of 18, or negative 18. Let's simplify the square root of 18. We know that negative is going to show up as an I. This is 9 times 2, so that's going to be 3 times the square root of 2. So we would write our answer as 3. The I would come in the middle, and then root 2. Okay, and so finding zeros, how does this relate to finding zeros? So that's how we would solve a quadratic equation. But to find the zeros of a function, so if we said f of x equals 4x squared plus 20, basically to find the zeros, the first thing we need to do is set this y value equal to 0. So remember, that's when we're on the x-axis, is when the function equals 0 or when y equals 0. So remember, guys, f of x simply means y. So setting y equal to 0, and now we'll just solve. We'll subtract 20 from both sides. And so there's our negative number, right, opposite of our square. Divide by 4. So we get negative 5 equals x squared. Take the square root of both sides. And we get x equals plus or minus 5i. Okay. So the zeros are positive 5i and negative 5i. And then you can do a check. You can actually plug this in and solve. So let's do that quick check. 4 times, let's do one at a time, the positive 5i plus 20. Does this equal 0? And so we'll square the 5, that's 25. Square I, so we get I squared here. Remember, that's negative 1. So we'll have 4 times 25i squared plus 20. Does that equal 0? Let's simplify this, right? This is 5 times negative 1. So we'll have 4 times negative 5 plus 20. Does that equal 0? Yes, it does, because this is negative 20. This is positive 20. And that does indeed equal 0. And so you could check it with the negative 5 too. But you're going to square away that negative. This is going to become positive again, and you'll still end up with this exact same chain. And you can check it in the book on page 107. Okay, so that's finding zeros. in a quick little video. We can do more of these together in class in the future.